Across the globe, there is a growing recognition of the importance of scientific research and the contributions of dedicated individuals in various fields, from medicine and technology to environmental science and engineering. The achievements of these brilliant minds not only enhance our quality of life, but also inspire the next generation to reach for their stars. Let's all welcome your guest and my guest. With an honor, Professor Ali Chamkha, Dean of Engineering at Kuwait College of Science and Technology. It's really a pleasure and honor to have you, Professor Ali, in Good Morning Kuwait.
Good morning, Mr. Farid. Thank you for the invitation. I'm honored to be with you.
Definitely, it's really, first of all, I feel really honored, to have somebody like you in your position, with all these publications. And really, I read your CV and something amazing. I mean, it's really rare to see CVs like that heavy and that long, honestly.
Thank you. The honor is mine.
Professor Ali, first of all, would you tell us about the Stanford University list of top 2% world scientists and your latest ranking in mechanical engineering?
Thank you, Mr. Farid. Good morning, Kuwait. In 2020, a group of scientists at Stanford University in the US have compiled a list of ranking of scientists in all fields, 22 major fields, and 174 minor fields, among them the mechanical engineering and transports field, which is my area of research.
Yeah.
They have ranked them in 2020 based on their publications through a composite index, which is covers or entails to includes number of publications, years of publications, career-wise, beginning, for example, my career started in publications in 1991 until 2024.
Oh, sure.
Throughout this period, what is the number of publications, what's your H-index, which is a measure of quality of your research, how people cite, number of citations, H-index, your position in the publications, first author, last author, middle author. Based on this group, they got an index and they ranked people according to that index. Alhamdulillah, in 2020, I was ranked 21st at the Arabic world level, first in the Arabic world, and number 21 in the world. Then 21, 22, 23, 24, I ranked 20 in 21, and then 23, then 20, then 14 last year. This year I'm 10 worldwide in the rank number 10, and still for the 5th consecutive year I'm number 1 in the Arabic world, alhamdulillah.
And number 14, 10.
Now I'm the 10th worldwide for the career long. Career long. Yeah. Now they do two things, career long and one single year, which is the 24.
Okay.
For the single year, I'm number 2 in the world and number 1 in the Arabic world.
So it's all based on also the number of publications.
Number of publications, quality of publications, driven or measured by the number of citations that people cite your work.
Exactly.
And you're ranked in the H-index. H-index measures. It's related to the number of publications as well as the citations, which impacts the impact of your work in the scientific field.
So how do you feel about being recognized as one of the top scientists in the world?
Being recognized as a top scientist in the world really gives two things. It's an honor, both an honor and a profound responsibility. It validates long year of hard work, dedication and collaboration, in addition to enforcing my contributions to the scientific field in mechanical engineering.
Professor, can you tell us about the challenges?
There are many challenges when you do research.
As an Arab, going to the Western societies, definitely the barrier of language, basically the customs, the whole system, the culture, definitely. You've faced a lot of challenges.
Yes, I've started work in the US, of course. I graduated, got my PhD in 1989. In 91, I started my first publication. I was a great teacher. My first love is teaching. My passion was research.
Wow.
So I started to do research after my PhD started writing publications on my own, sending it to journals, and I got accepted from the first time.
Yeah.
And that helped me, to energize and motivated me to do more work.
Yeah.
And I started working publications, and I found good acceptance in that field. In 1993, all my publications started in Kuwait. I came to Kuwait University, started at Kuwait University in Mechanical Engineering Department. I published tremendously. I started this path of publications and being cited. In 1999, approximately, I was recognized by top scientists. They started contacting me to collaborate with me.
Nice.
So this recognition added more reputation and recognition worldwide in the field. And then over time, I became a senior scientist, and I mentor young scientists and students and PhD students and stuff. The challenges were not having PhD programs in Kuwait, so that I don't have, most professors need graduate students to work on the research so they can produce and publish together. For that, I resolved it. I started collaborating with scientists abroad who have graduate students, and then their graduate students became my graduate students. And then I started producing through them, giving them ideas to do some research.
External and
internal. So resource management. So started having graduate students. I co-advised many PhD students, and they became doctors now, and they have students, and they are my grand students.
That's really a smart way of,
yes. And then, therefore, I continued producing, and I produced a lot of publications. For example, I've published more than 1,300 publications in about 33 years.
We're talking mostly about,
mechanical energy area, but mostly in mechanical, chemical engineering, something, because it's...
So, if I may, Professor, what is the main research or publication that really made you globally recognized?
Actually, my work on nanofluids, about 50, about 15.
So it's nanotechnology.
Yes, about 50. My area of research in PhD and masters and PhD degrees were in multi-phase flow, fluid particle suspension, a fluid with particles suspended within the fluid, microparticles. That was an important, intrinsic, it's very complex situation that I've worked in. I published initial work on it. About 15 years ago, an area of nanoparticles, suspending of nanoparticles of nano size in fluids. The particles become suspended in the fluid. Then we found a improved phenomena of enhanced thermal conductivity. Enhanced thermal conductivity from technical point of view means that you can enhance the transfer of energy between systems, and you can absorb energy. For example, in solar systems, what you need, you have the radiation coming to the system. If you have a fluid within the pipes, if you have particles, the particles attract energy more than a liquid because it has higher thermal conductivity. And that the system have higher thermal conductivity in the system. Therefore, you enhance the efficiency.
It becomes more efficient.
More efficient, and you have energy. By suspending a little bit, 0.1% by volume of nanoparticles. This area started, and then I jumped into that area. I left all other works in it, although my work works on multi-phase flow, fluid and porous media, filtration, nanofluids. So I started working on nanofluids 15 years ago, and I was one of the first people to tackle these type of problems, and I applied them to phase change material, the one that made a name for me, phase change material. Phase change material is a material that releases or absorbs energy based on solidification or melting. When you melt a phase change material to liquid, from solid to liquid,
like
it absorbs...
titanium dioxide could be?
Yes, it absorbs energy, and this energy you can use it upon solidification. Now this process is a slow process. By mixing nanoparticle, nano-enhanced phase change material, then you can speed in the charging and discharging of energy. And that was a big thing because we modeled it using some experimental data that was made a big impact in my field. And I was recognized for that in addition to other uses of nanoparticles. I can give you one important use of nanoparticles. Cancer treatment and biomedical applications. You know, when you have a person who have cancer cells, they do radiation. Usually you kill the bad cells and the good cells. Now, by directing the medicine with the nanoparticles to the bad cells, and you apply the radiation, you can kill the bad cells
cells
without
right away.
affecting the good ones. That was a
But
good
is
application.
this like applied now?
It's not applied because
Yet?
it needs about 5 to 10 years
More,
in
more
in the
research.
lab, in
Okay.
the labs.
Okay.
It has other applications, of course. In nanoparticles, using of nanofluids, the sky is the limit in terms of application.
That's true. That's
Yes.
true, because I remember during university years when we went to nanotechnology, we barely heard about the nano, and it came, they referred us to Richard Feynman,
Yes.
the American physicist, Nobel Prize winner, about his lecture. There is a lot of room down there.
Yeah.
The title of that lecture, and he was referring to nano.
You told me you're in electronics.
Yeah,
For example,
yeah,
cooling
yeah.
with electronic equipment.
Yeah.
For example, you use nanoparticles
Yeah.
for cooling systems.
That's true.
You can use that because you can absorb all the heat from the
Actually,
systems.
my project was investigation type project thesis, and it was about titanium dioxide, how it has, the basically flexible refraction index, and how the microscope, went to nano when they start, basically when the wavelength of the object smaller than the wavelength of the light,
Yes.
then we have a problem.
Yeah.
And then he start, putting
the
titanium
night-
dioxide and capturing the sub wavelengths.
Yes, because when you work at the microscopic phenomena,
Yeah.
it's a different phenomena
Exactly.
at the nanoscale phenomena.
Exactly.
And this is exactly what we're talking about. My initial multiphase flow was microparticles of micrometer size. When you go to the nanoscale, we found a totally different phenomena that impacted the field of nanotechnology.
That's really exciting,
Thank
Professor Ali, and it's really an honor really to hear such things, because it's really rare we have guests such as your
Thank you.
kind. So what inspired Professor Ali to pursue this area of research?
Actually, initially, I chose multi-phase flow because of its intrinsic complexity. It's a complex system to see explore how nanoparticles or particles move within the flow characteristics, to see how the streamlines of fluid along with the stream of particles impact the interfaces between the fluid and the particle. It's a complex system. In addition to the high application, it applies to energy systems, cooling systems, refrigeration systems, environmental applications.
Especially
it has a high level of applications. So these things inspired me to work in this area because of its impact.
It's really something important for our continent and peninsula, because
Yes.
we have really heated weather in the summer.
Solar energy
and
is,
solar energy, that's true, unfortunately is not
Exploited.
basically exploited enough, and that's the problem. So what methodologies did you employ in your research, and why they were effective? Is this because we're talking about nanogate, this new era?
No, actually, the methodologies you use in research, as you know, probably being an engineer, you do experimentation or modeling through softwares and computer modeling. I chose computer modeling from the beginning because working in multi-phase flow was very expensive in the US. To have particle counters was $100,000 at that time in 1989. So therefore, it was very complex to do to the lab. You need budget, you need resources, you need all of that, and then you don't control your destiny when you're working with them, because it depends on the equipment. When the equipment comes to the lab is set up, not set up, it's not your own field.
Yeah.
Therefore, doing a computational modeling, computer modeling, you have used the skills, you learn the softwares, and then you apply, and then you can produce a lot of data with no time, just the running time of the computer. So you have many situations you can alter so that you can produce the physics of the problem. So I chose that to do computer modeling. I wrote my computer codes in Fortran at that time, and I was able to produce a lot of results. When I produced results, I was reading a lot, keeping update with the simulations, and keeping update with the area, and know where the gaps and fill the gaps. And then this is why my publications were accepted quickly and solid. And this is so computational modeling is my main methodology. Sometimes when we have experimental data where we can validate the computational model, we have done it.
Professor Ali Chamkha, honestly, it's really exciting, the conversation with you, and it's really an honor to me.
Thank you.
I want you, because, we're out of time, I want to, this is your last message, or what would you like to say to the youngsters, to the students, to the students in high school, students in university, your sons and children?
I will tell them a strong message: to be curious, to be passionate about what you do, what to learn. Try to have the questions about what if, and try to seek knowledge.
Okay.
Be passionate about, love what you do and do what you love. Do what you love and love what you do. If you do that, you will always be successful. Be updated on the area that you're working in. Learn more, read more, write more. Have a strong communication skills.
See other publications.
Yes, see other publications, know the field. Build a core knowledge of expertise, that an area that you are strong in, and build on it over time. Then
that's a good methodology.
Yes, the process is a complex process. It has challenges. You will have failures, setbacks, and stuff. Don't consider them failures. Consider them learning processes, opportunities to build your experience, and then you will collaborate with others, collaborate with top researchers, mentors. Have mentors that will encourage you, motivate you to do your best, and then just be persistent, be dedicated, and do the right thing always. I will tell them that the process, the joy of the process, is as important as the final destination.
As Professor Ali Chamkha, the Dean of Engineering at Kuwait College of Science and Technology, be persistent, committed, dedicated, curious, passionate. All these words are really have a lot of meanings, in the field of study and in our life. Thank you very much, Professor Ali Chamkha, and it was an honor, and we hope to see you more and more on Kuwait TV.
Thank you, Mr. Farid. Thank you for Kuwait TV, and I'm really honored to be with you today.
Thank you.
Thank you.
Dear viewers, we'll go for a break. Please stay tuned. Don't go away. We'll be back.